Hey students, it's Mrs. Burke. Today I'm going to teach you guys a little bit about energy in the state of Washington, the place where you live. So we're going to take a look at actually how energy is actually made. So this is a little picture of a handheld, hand-generated flashlight. So I want you to take a look here and you're seeing the inside. If you actually had one of these, you would squeeze this handle, it would go up and down, these gears would move, and here's how the electricity is going to be made. There is a magnet. It is inside, um, and there are coils of copper wire on either side. As this magnet spins between the copper wires, an electrical current is generated, and that goes through these wires and it lights up this light bulb. Just remember, to make electricity, in this case, you need a magnet, a spinning magnet between copper wires. Seems pretty simple, but that's how we're going to be making electricity, let's say in a coal-fired plant. You take coal, you're going to burn it, it's going to heat up water. That water is going to create some steam. That steam is going to create enough pressure to spin this turbine. And that turbine is spinning, yep, you guessed it, a magnet around some copper wire, and that's going to create an electrical field. Now, coal is a fossil fuel, and so is natural gas. So you can think of this coal and natural gas plant the same thing. They're heating up water to make this spin, which spins the magnet or the copper wire. So let's take a look at nuclear power. The same thing, except instead of burning coal or natural gas, you're actually using nuclear fuel to generate enough heat to spin this, right? This is going to spin, this turbine is going to spin, and it's going to spin a magnet and some copper wire to create an electrical field, okay? Let's take a look at a dam. The dam is going to be really important to you because that's our main source of energy here in the state of Washington. You've got a big reservoir, big lake. It's going to allow a little bit of water through. It's going to spin a turbine. That turbine is spinning, yeah, I heard you say it, a magnet, some copper wire, and it's going to create electricity. And it's going to go over these big power lines right there. Okay, so how about a wind turbine? Same thing. What is spinning? You need something to spin that generator, that magnet, and that copper wire. So what we're really looking for is, can we get something to spin? That's what it's really all about. So here's our wind, the same thing. Okay, so let's take a look at the types of energy that we have, and I'm going to ask you guys these questions on Friday, so pay attention. All right, so we're going to take a look at works best on a clear day. That's going to be our solar energy. Is a fossil fuel that burns cleaner than coal, and that's going to be our natural gas. Produces radioactive waste, so the only one that can be is our nuclear, and has reached its maximum potential in the Pacific Northwest, and that's hydroelectric. We only have so many rivers, so many dams that we can build. And is the fastest growing source of energy here in the Northwest, and that is wind, our wind energy. All right, so let's take a look at why this is a big deal. Resources, that means the amount of coal, nuclear energy, natural gas that we have. Here it is, and the need. Notice that we're getting more people on the planet, we're going to need more energy. So the need is increasing while our resources are going down. So we've got to do something. There are some other alternatives that we are trying out. Here is a tidal or a current turbine that we're experimenting with. This is wave action. This is a big, basically, a turbine in here using wave energy. We have geothermal, it's taking the heat from inside the earth. And then there's this one, which is always kind of fun to talk about. It's poop, or what we call biomass or bio-waste. So we get it from cows, And then we actually are doing big experiments here in the state up north, and they're saving all the cow poop, um, and it generates its own gas. And they have a big pipe that pulls out the gas. You burn the gas, same thing, creates enough pressure um, to turn a magnet in the copper wire. So here's something else I want to teach you about, and that is something that is happening in your own house. They're called energy vampires. So these are things that are using energy all the time, but necessarily don't need to. So today, or sometime this week, I'm going to ask you to walk around your house and look for energy vampires. These are appliances that you have that are on all the time, that really don't need to. So anything that has a clock on it, a computer, um, DVD player, PlayStation, all of those are energy vampires. Now, that little light you may not think is a big deal, but if you take a look at this chart, you can see um, the yearly cost of all of these energy vampires. These are not, you're not using them, you're just letting them sit while they're plugged in. So while this may not add up a lot for your family, imagine or just project everybody in Kitsap County probably has a microwave that's on right now. So we're going to talk a little bit more about that in our Google Meet about what we can do about it. All right. So what you learned, types of energy, a little bit about how energy is created, some alternative sources, and some energy vampires. You can always go back to this because on Friday, you're going to have a little quiz. All right. Thanks for watching.